Shannon's entropy. Part 4. Equal probabilities. Shannon started by considering n events with equal probabilities. Then he moved to discuss rational probabilities, and after that he considered the general case of real probabilities. The discussion of equal probabilities is mathematically complicated, so embrace yourself. We will call the entropy of n events with equal probabilities A of n. If n is equal s to the power of m, then a of s to the power of m is equal m times a of s. It's like the example of throwing m dice we discussed before. We will call this x. Given s and t, we can choose n as big as we want and choose m accordingly such that t to the power of n is sandwiched between s to the power of m and s to the power of m plus 1. If we take log and divide by n log s, we get this. Pause and make sure that the math comes out all right. Because n is as big as we want, m divided by n can be as close as we want to log of t divided by log of s. We remember that and start all over again. This is where we started. Using the monotonicity of h, if the left term is no bigger than the middle term, and the middle term is no bigger than the right term, then we can show that. And go on like the previous slides. And conclude that m divided by n can be as close as we want to a of t divided by a of s. Pause and make sure that the math comes out all right. Let's look at the two results. Both a of t divided by a of s and log t divided by log of s are as close to m divided by n as we want. That means they both in the epsilon neighborhood of n divided by m, and the distance between them is as small as we want. And because all these functions are continuous, we can conclude that a of t must be k log t, which is what we wanted to show. Usually we take k to be 1 and the base of the log to be 2.